Welcome back, guys. So when you think ESP32 cam, you may think cheap and small, sort of like the clothes you find in a third world supermarket store. But you'd be mistaken. In this case, the developer AI Thinker has made it work and work well. In this video, we'll take a closer look at the ESP32 cam, we'll go over the Arduino IDE setup, what that looks like, and how to connect it so you can start using it with your Flipper Zero. Overview. The AI Thinker ESP32 cam is a compact and cost-effective camera solution for various applications. It measures 27mm by 40.5, so it's very tiny and discreet. The standard ESP32 cam can be acquired for about $10 to $15, while the more expensive version, the qflipper version, can be obtained for at least double the price. For this demo, we'll be using the first version. The ESP32 cam features a built-in flash and micro SD card slot, allowing for storage of images captured by the 2-megapixel camera, as well as additional files. The device also includes integrated Wi-Fi and Bluetooth connectivity, with the option for an external antenna to increase the signal range if needed. The board can be powered through either a 3.3V or 5V source, and despite its compact size, it provides 10 available GPIOs, which I personally think is quite impressive for the external peripheral front at least. It comes with a reset switch and is located at the bottom left of the device. However, it should be noted that the ESP32 cam does not include a built-in USB programmer. That feature is reserved for the more expensive model. Now, I first got wind of this project through a Reddit feed, and when we see the developer's GitHub repo, it seems that he's done very good work to get the foundation at least started for the camera usability for the Flipper Zero. So if we head over to his repo, we can see the popular repo is the flipperzero-camera. Now, if we see, we have a few files available to us within the repo. We have the FAT file, which was give us the application itself. We have the README, and we have the files itself for the sources. Once the application's installed, we have a few usage case scenarios where you can increase the contrast, decrease the contrast, invert colors. You can press the right key to toggle the differing, and you can also press OK to save any images to the SD card and back to close the application. So here's a demo of it by the developer's front, but we're going to want our own demo, of course. So in terms of releases, it's been last updated 2 weeks ago. We can see that right here. And there's some instructions for us to install and follow. So let's get started with that. So the first thing for me to do is prepare the jumpers. Now, I have some DuPont wires. I'll leave a link below, which work very well, but you can use any type of jumpers that you need. So if we put this over here, we can see exactly how we want to do this. So let's get started by pinning the GPIO pins to the necessary ports that it needs to be on both the camera and the flipper. So the first one here we see is the VCC. That needs to go to the 3 volts 3 here. So it's the VCC here. We need to pin that into number 9. Bam, that's done. Next one, we got ground to ground. Now we have a ground here. And we got that going to ground on 10. Next we have the UOR going to text, or TX should I say, and that's going to go right there. And we have the OT going to RX. We have the OT which is going to go into RX. Boom. Do not use the ground or ST, so don't use that pin on the camera. That's fine, we won't be doing that. Next, connect pin 100 straight to ground next to it on the ESP32. Alright, so here there's this one. So these two actually need to be connected together first. And then we shall take this ground and that could go into this ground instead. Alright, so scratch that first process. So 100 will go into ground, and then so these two are linked together like that. And this is just for the flashing process. And then we got this ground that can just go into port 8's ground. Alright, if you pause that and just copy that quickly, and then we can move on. Right, next we want to connect the flipper 0 to the computer using a USB. So once all the pins are hooked up as we have just done, we shall essentially connect the flipper and the camera to the PC using the USB-C. Right, now we can move on to step 5. We don't want to start qflipper up, so we can just bypass that. On the flipper 0 itself, we need to open the USB ARC bridge using the GPIO. Lovely. Now that's set. Now we can press the small reset button on the back side of the camera. And you should see a flashing light on the camera's board to acknowledge the firmware reset. Now we have to flash the camera. Now the current method to do that is to use Arduino, so let's set that up quickly. Now if we go into Arduino, we can go into preferences. Now we can go into additional boards, and then we can add the board that was required. There is a board in step 8 of the instruction list, and I'll leave it below just in case you can't see it. And that should be added into this additional board URL section. We press OK for that. Next, we want to install the ESP32 library. So if you go into board here and board manager, you can manage the boards. You're going to need this one, which is the Expressive Systems for ESP32 entire version, the 2.0.6 version, which is the latest one available. You're going to need that, and it's going to take maybe 5 to 10 minutes to install fully. Now then, once that's installed, we shall head over to board, then ESP32. Now within here, you're going to look for a board named AI Thinker ESP32 CAM. And that would be this one right here. It's right near the bottom. So we'll select that. Next, we want to establish the port has been opened. Now, if you followed the step before, which was to go into ARC bridge for the USB serial on the flipper hardware itself, now it should have opened up a port for you. So if you go into tools, then port, for me, I have port 5 available for you. It could be COM5 or COM4, depending on how the system actually processes it. But nevertheless, the port should be available now. So I have COM5 available. Next, within the GitHub, we want to download all the assets. So that's the source code, the ESP32 CAM firmware, and we want the camera.fat file as well. So now we need to upload this sketch in order to flash the firmware. So if we go into file and then open, and now we can open the I&O file that is within the zip file. Open that. Right, now we have the I&O file open. Now we can flash this onto the actual camera so we can interface with the flipper 0. Now what this code is doing when we call this include esp camera.h library is that it initializes the configuration module for the camera under that library set. The program then sets the necessary GPIO pins that we can see here for the communication between the camera and the device it's connected to, which would be the flipper in this case. The camera is configured for grayscale output with that QQVG that we can see here. And that's for the frame size that we're going to be using. In this case, it's the 160. over 120. Next, the program enables the serial communications and listens to the serial input from the user's control for the various camera settings that we can see is going to be set on the flipper dialers, such as we see in contrast, there's mirroring and differing. So essentially the code continuously captures images that's coming obviously from the camera and outputs those images over the serials. It's pretty cool. I do want to see the inclusion of the actual flash that's not done, so hopefully this can be worked on with the community to get that working as well. So once we're all set, we can hit upload, and that's going to upload it onto the camera. Now as you can see, it's compiling the sketch. Now at this point it's communicating with COM5. On the flipper you're going to see some flashing lights that is contacting, and we have a fatal error. Where is the error? We shall see. Now this could be a COM port in error because obviously it didn't communicate. So what you want to do is come out of the GPIO function on the flipper itself, go back into it again, and maybe even just disconnect it and then connect it up again. And then what we want to do again is hit the restart on the camera. Alright, so if we go back into tools and we're still on COM5, let's try upload that again. Again, it's having some sort of error communicating with the flipper. Now it's good that it's happening on a live demo, because I think sometimes it's unrealistic when things go right straight away with these things. So just securing all the ports down and making sure that the DuPont wires are actually secure on those connectors. And of course I had some loose ones, so let's try that again. Alright, that's more like it now. And we're done uploading. So we successfully flashed all of this code onto the camera. So that's a significant step when it comes to making this work. Now at this point I want you to take out that port 8 ground to ground on the camera to the flipper, because we no longer need it anymore because the flashing process is done. Alright, now we're back on qflipper once we had the flash process completed. Big up to SAS again for my unique screensaver. Now then, we can grab the FAT file, go into our SD card. What we want to do now is go into apps, tools, and then we see this camera FAT. That's within the source files from the GitHub. So grab that file and drag and drop it into this area. So that'll be this file, this camera.fap. You actually just take that file and literally drag and drop it here, and that's going to be within apps and tools, and then you're done for that. Now then, we got kind of the moment of truth to test. So if we go into the flipper now, we go into tools, applications, and tools. We can go straight to the bottom here. There we have it, the Esp32 camera. Now if we hit run on this, again it's asking me to verify the pins are connected. These pins do come off ever so slightly, it's very sensitive. So if we go back and then come back in, I think I'm missing one wire actually. I'm missing that ground to ground because I took it out. Ground can go into ground now on number 11. And voila, there we have it. Now what can it see? It can only be one thing to see. Jeez. Alright, trying to play with some of the textual settings here. But But my Guy Fawkes mask ain't holding up right. It looks scary as f***. Alright, that's the best I'm gonna get it, guys, but there you have it. The Ace's introduction to the Flipper ESP32 camera. Conclusion. Overall, I thought the ESP32 camera offered a convenient and budget-friendly option for projects that require small camera and all-in-one solutions. With its versatility, I might add, the ESP32 camera provides a multitude of potential application ideas to explore, from mounting it onto a sensory robot to add that vision. You could use it in terms of face detection if you're trying to write some Python scripts or code that can run that. You can potentially use it as a security application in some respects. You can use it in drone work. There's a multitude of application ideas that are at your disposal, and adding it to the Flipper Zero is just one on the many huge list of ideas that you can have. I hope you enjoyed that today. I thought it was a bit of educational on my part, especially getting hands-on, not so much on code, but with the DuPont pins and the alignment was quite fun. Make sure you like and subscribe if you haven't already. Join Hacking Time Discord, of course, and stay safe in the cyberspace. Peace out.